page 27. Okay, so particle moves along a straight line so that at time t greater than 0, position of the particle is given by s of t. V is v of t, acceleration, velocity is v of t, acceleration is a of t. Which of the following gives the average velocity? So average velocity is change in position over change in time. Okay,
which is slope.
Right, which is slope of position, yeah. This here gives average position, this gives average acceleration, this gives average acceleration, and this is change in velocity here. So yeah. However, there is another way to represent average velocity. You can always write, you can also write, it's not one of the options here, but average velocity is also 1 over b minus a, integral from a to b of v of t dt. Yeah, because then this will turn into s of t, and it'll be s of b minus s of a or b minus a. Yeah, so it ends up being the same thing, but given a different form.
So you use that one and just wrote when you have velocity. Say you don't have the initial values when or like position. Would you not? Would you then use whatever v minus a, or does it matter?
Oh, right. So this is the general formula for average velocity.
Yeah.
If it was like 2 1/8, it would be 8 and or 8 minus 2, and then from 2 to 8. So it'll end up looking like this: 1/6 times s of 8 minus s of 2.
Right.
Yeah. I just want to show a different initial look for average velocity. It could look like this, but ends up, these are the same things. Sine is an antiderivative of f, and so therefore the integral of f of x. So this is calculator portion. So we just enter this into the calculator. Oh wait, I'm sorry. Yeah, so this so it says that the integral, it says that this is the antiderivative of f. So we're not going to actually find the antiderivative of sine. It actually is the antiderivative. So we know that it's just simply sine of 1 over x squared plus 1, and then we can just plug in our bounds. So we don't make the calculator do it for us. Now, if it says that f of x equals sine of 1 over x squared plus 1, and it's asking for the antiderivative, then we would put it here and make the calculator do the work for us. But the wording here is telling us that this is the antiderivative. So we just have to plug in 1, 2, and 1.
So once I get to sine 1 of 5 minus sine 1/2.
Yeah, they can calculator plug in. Yeah, they can calculator do the work for you. Okay. Okay, function f is differentiable and increasing for all real numbers. X and the graph of f has exactly 1 point of inflection. For the following, which could be the graph of f prime, the derivative of f. So if our function is always increasing, that means our f prime graph is above the x-axis. There's a point of inflection. That means there must be a peak or valley on the f prime graph. Okay, so the only two graphs that are above the x-axis at all times are A and E. But then there's only one point of inflection, so there's only one peak or valley that we are looking for. So only A. There's too many peaks and valleys for E. Yeah. Okay. A vase has a shape obtained by revolving the graph y equals 2 plus sine of x from 0 to 5 above the x-axis where x and y are measured in inches. What's the volume? The vase. Right. So yeah, about the x-axis. So we have our graph here. It's bounded. Zero to 5. Rotated about the x-axis, so this method. One radius is needed. Top minus bottom. And we're going to put it into this r squared formula. Okay, radius r of x 2 plus sine x minus 0, or just 2 plus sine x.
Should 0 to 5,
Yeah, good.
2 plus sine x squared.
Normally, I would include the pi by itself, but in this case, looks like they're multiplying that pi through. So 25 times pi going to be around 80. Okay, the table gives values of function f. Function is twice differentiable. You know it's a smooth curve. And this is something that we're going to use here. F double prime is greater than 0. So we know the graph is concave up, which means that your slope is increasing. Or in other words, becoming more positive. Which of the following could be the value of f prime of 3? Okay. So we want to know what could be the slope at 3. Well, best we can do is find slope between the endpoints or between each of the ordered pairs and see what we get. So we do change in y over change in x. So we do 3.6 minus 2.4 over 3 minus 1. Plug that in the calculator, we get 0.6. So the slope between 1 and 3 is 0.6. The slope between 3 and 5, 5.4 minus 3.6 over 5 minus 3 is 0.9. Now, these numbers are very important because it tells us that we want these slopes to be ever increasing. So 0.6, blank, 0.9. What are the possibilities? It could be 0.7, it could be 0.8, but it can't be 0.6, it can be 0.9 because my graph is always concave up. It needs to continually increase. So the slope at 3, it's got to be somewhere between 0.6 and 0.9. The only option there is be 0.7. Okay. Number 81, at time t equals 0, forest preserve has a population of 1,500 deer. At the rate of growth, the population is modeled by R of t. What's the population at t equals 3? So if you can recognize the need for this final equals initial plus displacement, it just feels like a really easy setup. Right? You know the formula, it just, it becomes easier. So I'm looking for population at year 3. I know population at year 1, so I just need to figure out how much did the population change in that 3-year period added to my initial population, and I can get my population at 3 years. Okay, 82. We're looking at a derivative graph, so it's important that we know how to mark up our derivative graph, that we know how to create our derivative sign line, how to create our second derivative sign line. So critical points comes from your x-intercepts for your f prime. Above the x-axis is going to be where positive slope occurs. Below the x-axis, negative slope. And then for your second derivative sign line, your points of inflections are your peaks and valleys. So in this case, -1, 2, and 6. And then the slopes of the f prime graph is going to indicate the concavity of your original graph. So negative slope, concave down, positive slope, concave up, negative slope, positive slope. And if you can create your sign line correctly, then the options become a lot easier to choose from.
Well, I wouldn't like, so at the beginning, when it like kind of evens out, it's not a POI because it doesn't go from negative to right, so.
Yeah, you're right, it does even out, but technically we're still considering this as a potentially just a still negative slope. But you're right, yeah, it's a slope 0, it's a critical point potentially, but it's not a point of inflection. It's got to be a peak or valley or peak.
Okay.
Yeah. So here, if you look, this is concave down. Concavity 0, concave down. So there's no change in concavity. So that's why I left off that. But that could have included that there, but no reported question there. Okay, so let's see, we can set up our information that we have in front of us here. We want to find the integral from 0 to 3, 1/2 f of x minus 3 g of x. I'm just going to go ahead and split this up, try to break it down into its easier parts so I can see all the different pieces in play here. So we're asked to figure out the integral from 0 to 3. We have 0 to 6, we have 3 to 6, we have 3 to 0. So I think we can play around with these two to figure out this integral. And then we can flip this one to get what we want from g of x. Okay, so I'm going to work with these two, see if I can figure out something that makes sense. I know that integral from 0 to 3 plus integral from 3 to 6 must give me the integral from 0 to 6, right? So I know this is true. So if I start off with an equation that makes sense, I can just fill in the blanks here. So 0 to 6 is 9. 3 to 6 is 5. So therefore, 0 to 3 must be equal to 9 minus 5, which is 4. So I'm going to have to. Right, it doesn't give me it explicitly. I have to kind of work at it to get to that number. And then the integral from 3 to 0 is -7. So I can just flip that around and say, well, if I can just put the bounds 0 to 3 is equal to 7. So I can replace this f of x with integral of f of x with 4. And replace this integral g of x with 7. I can just multiply through. So 1/2 4 is 2. 2 minus 21. Okay, 84. The regions A, B, and C in the figures are bounded by the graph. The area, so make sure you understand that they're telling you the area, but if you see regions above and below, you got to make the appropriate sign changes. Region A is 14, region B is 16, region C is 50. What is the average value? So average value, we set up using average value theorem, 1 over B minus A, integral from A to B of f of x. My A is 0, my B is 8. So the integral from 0 to 8, I can just total those values up. The only thing you have to make sure is make sure you adjust that B is -16, right? Those are all negative y values. The area is 16, but the displacement is -16. '85 is easy if you know what the formula for total distance is the definite integral from a to b of the absolute value of v of t. So plug in the calculator, quick easy question there. Okay, 86. Longer. Okay, line T is tangent to the graph of y equals e to the x at the point of k, e to the k. So I know that we typically are a little bit more anxious when we see a bunch of much more letters here, but just think of that as just some unknown constant. Could be 3 e to the 3, or it could be 4 e to the 4, but just some unknown constant here. What are the positive values of k for which the y-intercept is 1/2? The y-intercept is 1/2. So tangent means that it's going to share the same slope at this point as well. So whatever that e to the k looks like, we're just trying to figure out the tangent line and also eventually what the y-intercept is. Right, so we're basically trying to figure out the equation of this line here, and then from there we can track it down to where that y-intercept is going to be. Okay. So let's go ahead and build our tangent equation. We know we have the order pair here. To find the slope, we need to find the derivative. Y prime is equal to e to the k times what's k's derivative going to be? Remember, 0. Yeah. I'm sorry. This is my bad. They start off with e to the x. My bad. No, not e to the k. K is a number, but the function is going to be the variable is going to be there. Yeah. So e to the x times 1. Oh, sorry. Still frozen. My bad. Okay, so e to the x times 1, y prime is e to the x. Okay, so then we can find the slope here. Slope is y prime of k. So y prime of k is e to the k. So that's my slope. Okay, some number, it could be 2, it could be 3, it could be 5. We don't know it yet, but from here we can just create our tangent line equation. This is my slope. This is my x1. This is my y1. You know, right? All letters here, no numbers. Now, we know that our y-intercept is 1/2. So that's the only clue that we have. So y equals mx plus b. We know that our b value is 1/2. Okay, so that's all we have to go on to help us get there, okay? But also, right, okay, so our b value is 1/2. Okay, so well, let's see if we can get this into slope intercept form. I know my slope is e to the k. So e to the kx, this is my mx right here. This is my mx, and this is my b right here. Oh, I'm sorry, I gotta add this plus e to the k. So my b is e to the k minus e to the k times k. So that's my b value. And my b value is 1/2. Right? Plug in 1/2 in for b. Bring everything over to one side. Now, this is a hard thing to solve, but we can make our calculator do the work for us. We can graph this and look for the x-intercepts. This is a really hard problem. It's almost not worth the time to go through this problem. However, this is part of a calculator question. So if you circle this, you could probably have time to work on it because you have so much time on the calculator portion. But yeah, this is one of those problems that, if it's on the non-calculator section, you almost just want to, circle it and come back to it, especially if you know it's a really long problem. So if you graph this, now remember, your calculator only handles x's. So it'd be e to the x minus e to the x times x minus 1/2. You graph it, you look for the x-intercept. Whatever that x-intercept is, that's your answer. Really tough one. Okay, 87. Actually, let me stop there and we'll pick up this afternoon.